All right, y'all. So 20 questions on this test. So the first one wants you to select the sketch that describes the end behavior. All right, so they're giving me f of x equals negative square root of 7 x to the third plus 3x squared minus 5x plus 2. So y'all, I'm going to bring up a chart that y'all can use on your formula sheet that might help you on this test, because I'm going to have 3 different questions where I use this chart. So you look at the degree, whether it's even or odd, and then you look at the lead coefficient, which is the number in front of the variable with the highest exponent. Okay. Now, the lead coefficient can be positive or negative. So even in positive, both sides go up. Even and negative, both sides go down. If your degree is odd, odd with a positive lead coefficient goes uphill, and an odd degree with a negative lead coefficient goes downhill. So y'all definitely want to use this chart on this test, okay? Alrighty, so for me, my degree is a 3 here, and that 3 is odd. And my lead coefficient is a negative square root of 7. So that thing is negative. So when it was odd and negative, so here you go, odd and negative, it will go downhill left to right. All right, y'all. So good idea to get that chart for this test, okay? All right, second question. We're going to use substitution to determine whether 2 is a 0 of f of x equals x to the third minus 10x squared plus 13x plus 5. So if 2 is a 0 of this polynomial, then when I plug in 2, I got to get an answer of 0. So if I get 0 for the answer, I'll put yes. Any other number, we're going to put no. So y'all, we need to find f of 2. So that'll be 2 cubed minus 10 times 2 squared plus 13 times 2 plus 5. So I'm going to work it by order of operations. First thing I'm going to do is the exponents. So the exponent for this one is 3. So 2 to the third power. 2 times 2 times 2 is 8. Minus 10 times what I get when I take 2 and square it. So that's 2 times 2, which is 4. And then I'm bringing everything else down. So I just did the exponents on that step. Y'all, this step, I'm just going to multiply the 2 places where I got to multiply. So that'll give me 8 minus 10 times 4 is 40, plus 13 times 2 is 26, plus 5. All right, y'all, now I'm going to go left to right, adding and subtracting. So 8 minus 40 is a negative 32. Negative 32 plus 26 is a negative 6. And then that negative 6 plus 5 gives me a -1. So y'all, since I got a -1 on this, that means that this is no, not a 0. So MATLAB will have a yes or no, and you just pick which one it is, okay? If you get 0, you're going to put yes. Any other number like I got, you're going to put no. All right, also going to move this down a little bit. So the third one wants me to find the zeros and multiplicity. So they're giving me f of x equals x to the third times x minus 4 squared times x plus 6. All right, y'all. So the exponents give me my multiplicity. So the x has multiplicity to 3. The x minus 4 has a multiplicity 2. And y'all, this one don't have an exponent out here. So y'all can chat me this answer. But what exponent would I put out here for the x plus 6 factor? All right, good job. That'd definitely be a 1. All right, so those are the 3 multiplicities. Now to find the zeros, we set each of the factors equal to 0. So we'll set this x equal to 0. Y'all, that one's done. It's solved. Then we'll set the x minus 4 equal to 0 and the x plus 6. So to solve this one, I'll just add 4. And I get x equals a positive 4. And then to solve this one, I'll subtract 6 and get x equals a negative 6. So MATLAB will come in and say the smallest zero is blank. It has multiplicity blank. The middle zero is blank. It has multiplicity blank. And then the largest zero is blank. It has multiplicity blank. So MATLAB will have this for us. We just got to put everything in. So y'all, the smallest zero, you got a 0, a 4, and a negative 6. The negative one's going to be your smallest. So you'd put negative 6 in. It came from this factor, which had a multiplicity 1. Right, the middle zero is going to be the 0. So the 0 came from this factor that had a multiplicity of 3. And y'all, my largest zero is going to be the positive 4. And positive 4 came from this factor, which had a multiplicity of 2. So, y'all, that's the trick on that one. You're going to get 1 negative, 1 0, and 1 positive number on those, okay? All right, y'all. So, number 4. All right, let me move this camera back up. So, number 4, we're going to find the zeros. And their multiplicities. Now, the difference in this one and number 3, this one we're going to have to factor to solve it, okay? So they're giving me f of x equals x to the third minus 4x squared minus the x plus 4. Now, the only difference in my problem and y'all's problems will be where I got 4s. Y'all will probably have another number there, okay? But this is a 4-term polynomial, and y'all, the way I solved this, I factored it by grouping. I factored the first two together and the last two. Now, out of the first two, I'm going to factor a GCF of an x squared. And if you divide both these by x squared, you get an x minus 4 in parentheses. Now, the second GCF will be negative since this third term is negative. So the second GCF always has the same sign as that third term. And y'all, there's only one number that I can factor out of an x and a 4 that would be a common factor, and that's going to be a 1. So your second GCF will probably be a negative 1, just like mine. All right, so negative x divided by negative 1 makes that a positive x. 4 divided by negative 1 makes that a negative 4. All right, the parentheses got to match up at this point. So the next step, since the x minus 4s match up, we're going to factor them out like a GCF. And y'all, when we factor out that x plus 4, what's left? The x squared minus 1 goes into second parentheses. At this point, we are factored, and we're going to take this and set it equal to 0. Now, there's no exponents outside of these parentheses at this point, so we would treat both of these like they are 1s. So that means when I'm done, all the factors I get will have a multiplicity of 1, okay? All right, so we set both these equal to 0. Now, y'all remember up here, since your highest exponent was a 3, that tells me we got to get 3 zeros out of this. So I'll get 1 here, and then since that's an x squared, I'll get the other 2 zeros from this one. So my first 0, to solve this, I'm going to add 4 to both sides. And again, x equals a positive 4. This one, since it's x squared in a number, I'm going to add to 1, move it over, and then do square root. So I get x squared equals a positive 1, and then I would square root both sides. So since you're taking the square root of a number, don't forget to use the plus or minus, so that I get x equals a plus or minus square root of 1, which is 1. So for this one, we'll put in the zeros are blank. Well, y'all, my zeros are 4, 1, and negative 1. And then each 0 has a multiplicity of 1. So y'all will all have a 1 here for the multiplicity. What y'all got to figure out is y'all's 3 zeros, okay? Alrighty, y'all. This one is true or false. If P of x equals x minus 5 to the 8th times x plus 4 to the 5th, then the graph crosses the x-axis at the point 5, 0. So we're going to figure out if this is true or false. Now, y'all, let me recall y'all on this. I look at these multiplicities to determine whether it crosses or if it's tangent. If the multiplicity is even, then the graph is tangent to the x-axis. If the multiplicity is odd, then the graph crosses over the x-axis. Okay? So what you got to figure out, you got a 0 of 5 here. We figure out which factor it came from. Well, it had to come from this x minus 5 here. So I'm looking at that exponent for my multiplicity. That is an even 8. So they're saying that the graph crosses at the x-axis. But y'all, we said if the multiplicity was even, it would come down, touch the x-axis, and be tangent to it. So this is false. Now the reason is because the exponent 8 is even, and therefore is tangent to the x-axis. So they'll have another one that says false because the exponent 8 is odd. Well, y'all, 8 is not an odd number, so that's where they get you on this one, okay? All right, y'all, so next would be number 6. 6 wants me to find the maximum real zeros, the maximum x-intercepts, and the maximum turning points. Now they're giving me f of x equals negative 9x minus x squared. So y'all, let's put our answers here. We got the maximum real zeros, blank, maximum x-intercepts will be blank, and then the maximum turning points. So y'all, let me ask y'all on chat. What do y'all think my maximum real zeros will be? Do y'all remember? All right, good job. It is definitely 2 because it equals the highest exponent. And y'all, real zeros and x-intercepts are the same thing. So if there's a maximum of 2 real zeros, there's going to be a maximum of 2 x-intercepts. Now the turning points, you take the highest exponent and subtract 1. So 2 minus 1 means I got 1 turning point. So this answer needs to be something like this. 221, 332, 443. These two numbers will be the same. That number will always be 1 less. All right, y'all. So for the function f of x equals 1/4 x squared minus 2. Match it to the graph. Well, these graphs will have, I'll show you, they're going to have 4 pictures. Both ends down, both ends up, downhill left to right, uphill left to right. So on that question, I would go back to this chart. Okay? So my highest exponent is a 2, so my degree is going to be even. This lead coefficient here is positive. So if it's even and positive, I want the picture where both ends are going up. So I would choose the picture of the graph that looked like a parabola. Hey, also that chart, like I said, for number 1 works on number 7 and 8. 8 wants me to sketch the graph. Now, you can plug these into y equals and get the shapes of these two, okay? So on 8, they're giving me f of x equals negative x cubed minus 2x squared. So y'all, this time, my degree 3 is odd. My lead coefficient here is negative. It's like a -1. So it's odd and negative. So y'all, odd and negative would be this slot, which is downhill. So that graph, I would choose the one that looks like it's going downhill, left to right. All righty, y'all. Now comes the fun part of this test. We're going to be finding polynomials. So this would be number 9. We're going to find the polynomial degree 3 with zeros of -2, 3, and -8. So y'all, this is the one where I started with the zeros and worked in reverse by foiling eventually to come up with my polynomial. Now they said degree 3, so my highest exponent on this has to be a 3 when I'm done, okay? All right, so take the 3 zeros and write them as equations. X equals -2, x equals 3, x equals -8. Now you're going to add and subtract to get a 0 on the right side of each of these equations. So since that's -2, we're going to add 2 to both sides and get x plus 2 equals 0. For this one, I'll subtract 3 from both sides, and I get x minus 3 equals 0. And y'all, the last one, I'm going to add 8 to both sides, and I get x plus 8 equals 0. All right, once I got them all set to 0, my next step was to put all these factors in parentheses and set this whole thing equal to 0. All right, so now's the fun part. Now I'm going to FOIL 2 of these at a time. So I'm going to FOIL the last 2, so I'm going to bring this x plus 2 down. And I'm going to go to the side and figure out what an x minus 3 times x plus 8 gives me when I FOIL it. I'll then put that answer here. So y'all, x times x is x squared. X times 8 is 8x. -3 times x is -3x. And then -3 times 8 is -24. Adding the like terms in the middle, I get an x squared plus 8 minus 3 is 5x minus 24. So I'm going to put that right here now. and set this all equal to 0. All right, so now I got it left now is to multiply this. Okay, so I'll go on the side over here and multiply that one. X plus 2 times x squared plus 5x minus 24. All right, y'all, so multiply this x by all three of these. X times x squared is x cubed. X times 5x is 5x squared. X times negative 24 is a negative 24x. Now multiply 2 times all three of these. 2 times x squared is a 2x squared. 2 times 5x is 10x. 2 times negative 24 is negative 48. So let me add my like terms. So I got my x cubed. 5 plus 2 give me 7x squared. Negative 24 plus 10 gives me a negative 14x. And y'all, at the end is my negative 48. So this gave me x cubed plus 7x squared minus 14x minus 48, all equal to my 0. So y'all, here's how MathLab has the answer. They got f of x equals x cubed plus blank x squared minus 14x minus 48. So we did this whole problem to find what number goes in that box. We got our x cubed, so that needs to be a plus 7x squared. So we would come in, put our 7 in the box, and then notice everything else matches up. So notice we did a lot of foiling, and when we're done, our highest exponent was a 3. And y'all, that's what they said we needed, a degree 3. All right, number 10. Y'all, this one's sort of similar. Well, it's really similar to how I'm going to work it, but they're giving me different numbers here, okay? So this one says, find the polynomial lowest degree. So they're not giving away what the exponent should be on this one. They're just saying lowest degree with zeros of square root of 3, negative square root of 3, and 2. So the difference is this one's giving me a couple radicals on this one, okay? But y'all, I'm going to do the same thing. I'm going to set each of these as an equation. So x equals a square root of 3, x equals a negative square root of 3, x equals 2. I'm going to work it like I did up here. I'm going to add and subtract to get a 0 on the right side. So add the opposites to each. So y'all, we're subtracting square root of 3 gives me x minus square root of 3 equals 0. Adding the square root of 3 to the second one, and I get x plus the square root of 3 equals 0. And y'all, the third one, I'm going to subtract 2 and get x minus 2 equals 0. So once we had our 3 equations set to 0, we're going to put each of these factors in parentheses. So x minus square root of 3, x plus square root of 3 times x minus 2, and set the whole thing equal to 0. So y'all, I'm picky on this one. I would multiply these two first. So I'm going to come in and multiply the first two together first. So I'll do that on the side. I'll do x minus square root of 3 times x plus square root of 3. Y'all remember this. When you FOIL conjugate pairs of radicals, the radicals are going to disappear. Okay? And I'm going to show you how. X times x is x squared. X times the square root of 3 is a positive square root of 3 times x. Negative square root of 3 times x is a negative square root of 3 times x. Now these 3's are underneath, so I can actually multiply them. So a negative square root of 3 times a positive square root of 3 is a negative square root of 9. So if you notice, the middle two cancel. So I bring down my x squared minus, and y'all look here, the square root of 9 is 3. So remember, I told y'all back in, this would have been in 8.4, that if you multiply a radical times itself, it always equals the number under the radical, okay? So bring that over here. X squared minus 3. That was them two. Bring down to x minus 2. So y'all, that I brought over to here. Alrighty. So now we got to multiply these. All right, y'all. So on the side, I'll multiply them real quick. X squared minus 3 times x minus 2. So x squared times x is x cubed. X squared times negative 2 is a negative 2x squared. Negative 3 times x is a negative 3x. And then negative 3 times negative 2 is a positive 6. So this works out to a x cubed minus 2x squared minus 3x plus 6 equal to 0. So in MATLAB, we'll have our f of x and then bring down our polynomial. X cubed minus 2x squared minus 3x plus 6. And then y'all, when I multiply that, I put that right there. So this one would have an A, B, C, D answer on it, and you want the one that matches your polynomial, okay? Honey, so notice 9 and 10, a lot of fooling, okay? All right, y'all, so let's go to, so number 11 won't be as bad. All right, number 11. Suppose a degree 4 polynomial has some zeros of I, a negative I, and then 2 minus square root of 7. So negative I, 2 minus square root of 7, they want me to find the other zeros. All right, y'all. So the other zeros are, now look here, it's a degree 4, so altogether I should have 4. They're giving me 2. So y'all, this is where we wanted y'all to realize that if they gave me imaginary zeros, its conjugate would also be a 0. And if I got radical zeros, its conjugate would also be a 0. So the conjugate of a negative I would be a positive I. The conjugate of 2 minus square root of 7 would be 2 plus square root of 7. So you don't change the sign on the number 2. You only change the signs of the radicals, okay? All righty, y'all. So it looks like number 12 will be the last one where I got to do any foiling. So they want me to find the polynomial lowest degree with sum of the zeros of a negative 2i and 5. So they gave me some of the zeros. But y'all, based on number 11, we know this is not all the zeros because that's imaginary. So its conjugate must also be a 0. So that means 2i must also be a 0. Now, we don't have anything saying that regular numbers come in conjugates, only the imaginary or the square roots, okay? So that means I'm going to have 3 zeros. So when I'm done, my highest exponent has to be a 3. All right, so I got x equals a negative 2i, x equals a positive 2i, and then x equals 5. So when they say find a polynomial, that's when you're doing autofoiling, okay? So we need zeros on the right side, so add their opposites to each one. So I get x plus 2y equals 0. This one I'll subtract. X minus 2y equals 0. And y'all, this one I'll subtract also and get x minus 5 equals 0. All right, now I'm going to put them in parentheses. X plus 2y times x minus 2y times x minus 5, all equal to 0. All right, y'all, so you always want to start by multiplying the imaginary numbers first. So on the side, let's multiply the x plus 2y times the x minus 2y. Now, y'all remember, since these are imaginary conjugates, when I FOIL this out, the I will disappear. All right, x times x is x squared. X times negative 2y is a negative 2ix. 2y times x is a positive 2ix. And y'all, 2y times negative 2y is a negative 4i squared. So if you notice, the middle cancels. So bring down your x squared. So y'all, this question is for y'all on chat. What does I squared equal? Because if I know what I squared equals, that's going to eliminate those i's altogether. All right, good job. That is definitely a negative 1. So this is a negative 4 times a negative 1, which makes that a positive 4. So the complex imaginaries always end up being positive, okay? All right, y'all, so that'll go over here, x squared plus 4. Then I'll bring down my x minus 5 and still set this equal to 0. All right, so guess what? Now we get to multiply these together. And I'll just multiply them over here instead of going to the side because it's the last thing I got to multiply. So let's see what we get. X squared times x is a x cubed. X squared times negative 5 is a negative 5x squared. 4 times x is a 4x. And then 4 times negative 5 is a negative 20. All right, y'all, so let's see. I don't have any like terms. So in Math Lab, you would put in, they'll have the f of x equals, and you'll just put in this polynomial, x cubed minus 5x squared plus 4x minus 20. All right, y'all will be happy to know that that's the last one where I had to do all that foiling, okay? All right, so next we got some synthetic division coming up. So number 13. So this is number 13. So for the polynomial, one zero is given. They want me to find the remaining zeros. All right, y'all. So they are giving me P of x equals x to the fourth plus 72x squared minus 729. And they're saying 9i is a zero. All right, so this is where we're going to do synthetic division. And we're sort of going to divide out this zero to see what's left. Notice, the highest exponent is 4. That means I got 4 zeros altogether. They're giving me one of them. So that leaves me 3 to find. So I'm going to use synthetic division. And that's why I write down the numbers of the polynomial. But y'all, this one's missing 2 terms on it. Since there's no x cubes, that's like a 0x cubed would be in between the x4 and x squared. And then it's like we would have 0 x's in between the x squared and the number. So when you do synthetic, every placeholder has to be represented, okay? All right, y'all. So the coefficients I would write would be 1, 0, 72, 0, and then negative 729. All right, so I'm going to set up my synthetic division. And the first zero they gave me was the 9i. All righty. So since they told me 9i was a zero, my remainder better be 0, okay? All right, y'all. So remember, you bring the first number down, multiply by the 9i, put in the second column. So 1 times 9i is 9i. 0 plus 9i is 9i. 9i times 9i is 81i squared. But y'all, I squared equals negative 1. So that's going to make that a negative 81. All right, negative 81 and 72 is a negative 9. Negative 9 times 9i is a negative 81i. Notice I didn't get an I squared on that because this one didn't have an I. All right, 0 and negative 81i is negative 81i. So negative 81i times 9i is a negative 729i squared. But y'all, I squared is negative 1. So it's going to turn that negative 729 into a positive 729. And y'all, negative 729, 729, give me a remainder of 0. So we still have 4 numbers left. So since we still have 4 numbers left, we're going to do synthetic division again using these 4 coefficients. Alrighty, y'all. So I had a 1, a 9i, a negative 9, and then a negative 81i. Y'all, they didn't give me but 1 0, so tell me what is the next 0 y'all would check? Uh-oh, y'all, let me get y'all on that. Negative 9i, perfect. Remember, these got to come in conjugate pairs. So if they give me 9i, then I automatically got to try the negative 9i. Good job, Carla. All right, y'all, so here we go. Bring the 1 down. 1 times negative 9i is negative 9i. 9i minus 9i is 0. 0 times negative 9i is 0. Negative 9 plus 0 is negative 9. And y'all look here. Negative 9 times negative 9i is a positive 81i, which gives us a 0 remainder. Now we got 3 numbers, so now this becomes sort of quadratic. This would be 1x squared. That would be 0x's. So since it's 0x's, I don't have to write it. And then that would be my negative 9. So I would take this now and set it equal to 0 and solve it for my last 2 zeros. So once y'all get it down to 3 numbers, it's now going to be quadratic, okay? Y'all, to solve this one, x squared in a number, I'm just going to add 9 and do my square roots. So we get x squared equals 9, and then we would square root both sides. So that's going to be a plus or minus square root of 9. And y'all, I get x equals a plus or minus 3. So MathLab's going to say on this one, the remaining zeros are blank. Now remember, I needed 4 altogether. They gave me 1, so I found the other 3, which were negative 9i, 3, and negative 3. Y'all don't put the 9i in because it will mark it wrong if you put 4 in here. You can only put the 3 that you found, okay? All right, y'all, 14 gets into the asymptotes. So on 14, they want me to find the vertical asymptotes. All righty, they're giving me f of x equals x squared plus 4x minus 21 over x squared minus 3x minus 18. All right, so to find vertical asymptotes, we take that denominator and set it equal to 0. Once I got my 2 solutions, those are going to equal my vertical asymptotes, okay? So y'all, to solve this, you're going to factor. So x squared is an x and an x. This last number is negative. Anytime the last number is negative, you need a positive factor and a negative factor. All right, y'all, so give me this. Give me two factors of 18 that would subtract and give me a 3 like the middle. And then when y'all give me them two numbers, I'll make the larger one negative like the middle, and the smaller one would be positive. So what two numbers multiply to get me 18? Okay, Darren, you got it, 6 and 3. So the larger number is going to be negative like the middle, and then the smaller one would be positive. All right, y'all, set both these equal to 0. And let's solve them. So here we would subtract 3. Here we would add 6. All right, so these are basically my vertical asymptotes. So we would want the answer that said x equals -3, comma, x equals 6. So this one would have a multiple choice answer. Now y'all be careful, because let me show you on this one. Be careful because they put y on this. Y equals -3, y equals 6. That's not the one we want. We want to come and find the one that has x equals -3 and x equals 6. All right, there, put it in Zoom. Be careful. Do not use y for the vertical. The y will be down here for the horizontal asymptote, okay? All righty, y'all. So let's see. That was number 14, so we need 15 next. 15 wants me to find the domain. And then we're going to write the domain in interval notation. All right, y'all. So they're giving me f of x equals 2 over x squared minus 2x minus 35. So y'all check this out. Define a domain would be the same thing I did when I found those vertical asymptotes. I'm going to take the bottom and set it equal to 0. So y'all, once again, you're going to have to factor. So x squared is an x and an x. Once again, that last number is negative. So one factor is positive, one factor is negative. All righty, y'all, let's see if y'all can find me factors of 35 that would subtract and give me 2. All right, so they're going to multiply to get 35, but they're going to subtract and give me a 2. All right, that's going to be 7 and 5. Good job. 7 is a larger number. It'll be negative like the middle. And then the 5 would be my positive. All right, y'all, let's set these equal to 0 and solve this. So, y'all, I'm going to subtract 5 on the first one. I get x is a -5. Second one, I'm going to add 7 and get x is a +7. So the domain needs to be an interval notation. So the domain would start at -infinity. And let's see, we're going to hit the negative number first. So we're going to kick that negative number out by unioning around that -5. From -5, we're going until we hit 7. So we're going to kick out 7 by unioning around 7. And y'all, there's no more numbers to kick out, so I'm good as I head towards positive infinity. Okay, so you're going to get two numbers on that. You got to kick them out of that domain, okay? All right, y'all, let's see. This 16, we're going to determine the horizontal asymptote. So that's where I looked at the biggest exponent on top and bottom. If the exponent on top was larger, there was no horizontal asymptote. If the exponent on bottom was larger, then it was y equals 0. If the exponent on top and bottom were the same, then we looked at the ratio of the a over b, which was the lead coefficients. So y'all, for this one, they're giving me f of x equals 4x to the fourth plus 3 over 3x to the fourth minus 4. So y'all look, the biggest exponent on top is a 4. Biggest exponent on bottom is a 4. So the top degree equals the bottom degree. Okay, so these are equal, the largest exponents. So that means that my horizontal asymptote would be the ratio of A over B. So y'all, here we go. Y equals A over B are going to be the numbers in front of these variables. So A is 4, B is 3. So Y equals 4 over 3. Now they'll give you the Y equals part. All you're putting in is the 4/3 on that one, okay? There you go, 17. I'm going to find the domain. Um, any asymptotes, but they don't ask for those. And then it wants the x and y intercepts. But I'll find the asymptotes so that I can pick out one of these pictures, okay? And then graph. All right, so let me pull this down. My function is f of x equals 3x plus 1 over x. So to find the domain first, to find the domain, I'm going to set the bottom equal to 0. Well, y'all, that's done. I can't do nothing else for that. So the only number x cannot be is a 0. So remember, I'm doing my domain in interval notation. It'll be from negative infinity to 0, union around 0, until we go to positive infinity. Next, they asked me for the x-intercept. So to find the x-intercept, I set the top equal to 0. All right, y'all, let's solve that. We're going to subtract 1 from both sides. So 3x is negative 1. Divide by 3 on both sides. So that cancels, and I get x equals a negative 1/3. But remember, the x-intercept has to look like an ordered pair. So this would be negative 1/3 and 0. All right, next they wanted the y-intercept. So to find the y-intercept, I find f of 0. That would be 3 times 0 plus 1 divided by 0. All right, y'all, so this, you cannot divide by 0, so this is undefined, which means that there is no y-intercept. If you got a single x in that denominator, you will not have a y-intercept, okay? So my domain was negative infinity to 0, union 0 to infinity. My x-intercept was negative 1/3, 0. I have no y-intercept. Now, to help you pick the graph, at this point, y'all, you could go to y equals and plug it in, or you could actually find your vertical asymptote and your horizontal asymptote. The horizontal asymptote, well, y'all, these are equal. That's an x to the first. That's an x to the first. So the top equals the bottom. So since the top equals the bottom, my my horizontal will be my a over b, where a and right here, a and b are these numbers. Now this x don't have a number in front of it, so you would treat that like a 1. So my horizontal asymptote is 3 over 1, but y'all, that would simplify to a 3. My vertical asymptote, y'all, the vertical asymptote, you find it the same way you found the domain here. So that means you're going to set the denominator equal to 0, and you get x equals 0 for your vertical asymptote. Okay? Alrighty. So if I was to draw that graph, and y'all, we got small numbers, so I'll go out 5. All right, so what do I know? I know I got a vertical asymptote, x equals 0. So that's right here. I cannot cross the y-axis, basically. The horizontal was 3. So 1, 2, 3. So out here somewhere on either side, my graph is trying to approach that horizontal line. Now, the only other thing I know the x-intercept was negative 1/3, 0. So y'all, negative 1/3 and 0 would be about right here. Now that's the only place it crosses the x-axis. So that means this side has to come over, approach that x-intercept, and it's going to go straight down. So y'all, if this side's going down, this side's going to come from above. It's going to come down, curve, and try to get to the horizontal asymptote from above. Now, y'all, the only other way, you can go to calculator and graph that in y equals, okay? Put in your 3x plus 1 over x. And y'all, I'm going to do that real quick on the calculator to show you. So I'm going to go to y equals. Now, to make it look like a fraction, I'm hitting the green alpha button, y equals, and enter. So on top, I had 3x plus 1. Arrow down to the bottom, I had an x. And y'all, all I care about is the graph. So let's hit enter. And there you go. So there's it's trying to get to the horizontal asymptote on both sides. And notice it's coming down, crossing right at that negative 1/3. And then it goes downhill. So y'all, really, either way, if you want to do them by hand, you can sort of figure them out. Or you got that calculator, okay? All right, y'all. So that means 18. This is the stuff from Monday night that I sent y'all the video to watch. But y'all, if you're still confused, 18, 19, and 20 are doing that. So you could probably pick up from this. So these will all say solve the following inequality. All right. I will say this. If it does less than or greater than, when you do your interval notation, you'll use parentheses. If it's got equals under it, you're going to use brackets around the number. It's only around the number. The infinity always has parentheses, okay? So this would only be around the numbers if you got equals in them. Now on the test, they're all either going to be greater than or less than. You won't have equals on these three that I noticed. Okay? But in the homework, you did have, I think, one or two that had equals. So on those numbers, you would use the brackets on that, okay? All right, y'all, this has x minus 3, x plus 1 is less than 0. So these are already factored. So since they're factored, you're going to set both of these equal to 0. Now, I just use equal while I'm solving them instead of that, okay? So solve both of these by adding 3 here and subtracting 1 here. So I get x equals 3. Here I would subtract 1 and get x is a -1. So once you had the two numbers, you're going to come in and make a number line based on these two numbers. So the smallest one would be -1. The larger one would be 3. So now, what we got to do is find a test point and see if it's true when we plug it in. If the test point is true, you would shade that area. If the test point is false, you would shade the other areas. So what I mean is, this is either going to shade in the middle or it's going to shade on both the ends. But it's going to do one or the two, okay? Now, the test point I always use is 0. I'm going to test 0, which is in between -1 and 3. If 0 is true when I plug it into this, I'm going to shade between that -1 and 3. If it's false here, then I'm going to shade the two outer edges. So to test 0, I'm going to put a 0 in for those x's. So 0 minus 3 times 0 plus 1 has to be less than 0. So I'm looking for a true or false. So 0 minus 3 is -3. 0 plus 1 is 1. And y'all, -3 times 1 is -3, less than 0. That is true. So since -3 is less than 0 is true, on my number line, I would shade in between -1 and 3 because that's where the 0 was located. Now, you could have picked a number over here. You could have picked a number over here. It don't matter. I just think that 0 is the easiest number to use, okay? Now, interval notation. We're only good between -1 and 3, so interval notation would be parentheses, -1, comma 3, and be done. That is what MATLAB wants. So if it shades in the middle, you're going to have an interval that contains two numbers, and that's it. Now, if it shades on the ends, our interval would look a little different. So y'all, let's see what 19 does. We're going to solve the inequality. So same thing, except I got an x squared minus 17x plus 66 is greater than 0. So y'all, we got to factor this one to solve it. And I'm going to use equals just while I solve it, okay? So x squared is an x and an x. Y'all check this out. This last number is positive. Since that's positive, both of these factors will have the same sign as the middle. They'll both be negative. So y'all, what I need for this problem? Can y'all find me factors of 66 that add to equal 17? So give me two numbers that multiply to get 66, but when you add them, you get a 17 out of them. 11 and 6, good job. So that'll be minus 11, minus 6. Okay? Now, set both them equal to 0 and solve. So y'all, looks like here we're going to add 11. So I get x equals 11. Here I'll add 6. And I get x equals a positive 6. So my little number line, let's see, 6 is before 11. But y'all check this out. I'm still going to test 0 again. But 0's not in the middle on this one. 0's going to be over here before 6. I always use 0 because to me it's the easiest number to plug in and get an answer to. Okay? So I just figure out which one of these intervals my 0 is in and I use it. So I'm going to use this right here. That's going to give me 0 squared minus 17 times 0 plus 66 has to be greater than 0. Y'all check this out. That's gone. 17 times 0 is gone. So all I got left is 66 greater than 0, which is true. So if I'm looking at my number line again, I had a 6 here and 11 here. Since it was true when I tested my 0, I would shade the first section and the last section. Those two always get shaded together. The center gets shaded by itself only, and if you do the ends, they get shaded together. So now, interval notation for this one. It starts at negative infinity until it gets to 6. And then we'll union. We can't do 6 to 11 in here because that part's not shaded. We got to start at the 11 and go towards positive infinity. Okay, y'all? So if you're shading the ends, you're going to have negative infinity at one end, positive at the other. But do not include 6 to 11 because that's not shaded. Alrighty, then the last one says solve. I got an x squared plus 5 less than 4x. So y'all, for this one, I need to get the 4x over here because I need a 0. So I would come in and subtract 4x from both sides so that I get an x squared minus 4x plus 5 less than 0. All righty, y'all, next step, try to factor that. And then I'm going to use equals 0, okay? So x squared is an x and an x. Y'all, the last number's positive, so both of these will be negative like the middle. And y'all check this out. I need factors of 5 that add to equal 4. So let's see. 1 and 20, if you add them, you got 21, so that don't work. 2 and 10, if you add them, you get 12, so that don't work. Oh, y'all, I'm doing the wrong numbers. I'm looking at 5. There's only 2 ways to get a 5. 5 times 1, but if you add them, that's 6. Uh, But that's the only way to get a 5 is 5 times 1. But y'all, when you add them factors, you cannot get a 4. So guess what? This one does not factor. So since this does not factor, your answer is what we call the empty set or the no solution. And you got to use that 0 with the line through it. So when you click in the blank, this will be one of the options on it. And that is what we use for no solution. Okay? But you cannot write no solution. You got to use this 0 with the line through it. Okay? All right, y'all. So that is your review. So what I'm going to go for is give you your options on the test. So your testing options. All right, you can do this test by yourself using the Respondus Lockdown browser. So you can test on your own. Okay. Remember, this test is due Sunday night, which is the 12th. Option 2, if you cannot get the lockdown browser Respondus, you can test with me on Sunday night from 6 to 9. Okay. I'll leave it open for y'all if you come in and you can't start till 9. That's cool. And I'll give you till 10 or whatever. But you at least got to start by 9, okay? So it'll be between 6 and 9 Sunday night. And I'll send out a link later for that, okay? And y'all, your only other choice is with me after the college algebra lecture Monday. Okay, so we'll sort of do it during the support. And that would be, so we'll probably start that in around 7:15 or so. So I'll give you from 7:15 till, let's see, 8:30. So these two are with me either Sunday night between 6 and 9 or Monday between 7:15 and 8:30 after I do the college algebra lecture, okay? Otherwise, you're on your own to do it. And it'll be Sunday night, I think at midnight's when that expires. And also, y'all don't forget, I got bonus 3 sent out to y'all. That'll be due Sunday night. Okay, so I sent that in your announcements, and you should have had an email about it. Some of y'all done answered that, and all you had to do on that was tell me whether the number was a 0 or not. So that was just a yes or no question for y'all. Okay. So you cannot use all your notes, but you can use one page for anything you want to write on that page. Okay. Now I would recommend. Let me find it. So you can use the front and back of this page. I'm cool with that. But one thing I would probably put is this for sure, because 3 questions use this. And then if you need other notes on there, I'm good with that, okay? So, cannot use your whole notebook, but you could use one sheet, whatever you want. And you can use your calculator or your phone app. Now, y'all, here's the thing. If you use the phone app, you got to show me the app before you start the test. Either way you pick, okay? So if you're using that phone app on your own, you'll just hold that phone up and sort of show me that you're using the app, and I'm cool with that, okay? All righty, y'all. So let me stop my share. All right, y'all. So y'all have any other questions on this? So just remember, if you did not do the 8.6 and watch that video, then the last 3 questions on this review I did were questions like 8.6 had on them, okay? All right, y'all remember, do your module review so you can practice for this test. Because the module review counts as a quiz grade, and it's the best way to get ready for the test, okay?